Hi, in this video we're going to talk about solving linear inequalities. Okay. Now, up until now we've been solving equations, and this is a real simple equation that we solved. And our rules for solving inequalities are basically the same with one new rule. There's going to be one new rule. So we'll talk about that in a minute. But remember how we solve equations. We want to isolate our variable. All right, to do that, we need to, in this case, get rid of the 3. We're currently multiplying by 3. So we divide each side by 3, and I would get that x equals 3. Okay. When we move into solving inequalities, we're going to replace our equal sign with an inequality, something like this. Okay. Now, we have 4 different choices for inequalities. We can use less than or equal, greater than or equal. So we have 4 different inequalities that we can put in here. But again, our goals are going to be the same. We want to isolate our variable, okay? Whatever we do on one side, we have to do on the other, okay? So in this case, even though I haven't told you the new rule, to solve this inequality, we would divide each side by 3, just like we did up here. We would get x, we would get 3, and actually for this one, x less than 3. Now we want to always write these in interval notation, and in the last video we talked about interval notation. What is the smallest value of x that would make this true? That would be negative infinity. What is the largest value of x that would make this true? Well, it's approximately 3. And then we do our parentheses. We always use rounded brackets with negative infinity and positive infinity. And then, since there's no equal sign here, we would use a rounded bracket. Now, think about what this means. When we have an equation, we typically have one solution. That's what happens the majority of the time. The only value that works here is 3, because 3 times 3 is 9. But what this is telling me is any value from negative infinity up to 3 would work. So 0 would work, negative 2,000 would work, right? So we have an infinite number of solutions, and that's why we want to display them using interval notation. Now, I warned you that there was one new rule, so let's talk about that now. Our new rule for solving inequalities is if we multiply or divide. Okay, so it's very specific. It only applies if we're multiplying and dividing. If we're adding and subtracting, nothing has changed. If we multiply or divide by a negative number, right, we must reverse the inequality. So how would that work? Well, let's go back and do our example that we just did, and now in place of a positive 3, I have a negative 3. So in order to isolate my x, just like when I was solving the equation, I would divide by negative 3, divide by negative 3. These cancel, leave me x. 9 divided by negative 3 is negative 3. But notice here, I divided by negative 3. It meets our rule. If we multiply, well, we didn't multiply or divide. We did divide by a negative number. It was negative. It was a negative 3. So we must reverse the inequality. And reverse means that we take our inequality and switch it around. So my solution is going to be x greater than negative 3. Again, we can write this in interval notation. What's the smallest value of x that'll make this true? Negative 3. What is the largest value of x that'll make this true? Infinity. We would use round brackets. And now notice, if I plug in, let's say negative 2, I get negative 3 times negative 2, that's 6. 6 is less than 9. Check. But if I plug in something like negative 5, I would get 15 less than 9. That's not true. And notice that negative 5 is outside of this range. If we had forgot to reverse the inequality, we would have had x less than negative 3, which would have meant negative 5 works here. But we all know that if we take negative 5 times negative 3, it gives us positive 15, and that is not less than 9. So in order to solve this correctly, we have to adhere to this new rule. If we multiply or divide by a negative number, we must reverse the inequality. Now, if you're like me, you like to go to wedding dances, you probably danced once or twice to Mr. C, the Slide Man. And I am convinced in his cha-cha slide, the inspiration for part of his dance came from our rule for solving inequalities. Let's listen. That's right. His reverse reverse, I'm fairly certain he came up with in algebra class. When he was learning how to solve inequalities. Ha ha. All right, let's do some examples. But again, we'll keep our rules right by us so that we can refer back to it and see if we need to reverse. Okay, so here's our first example. Again, just to get started, pretend that there's not an inequality there. Pretend that you have an equal sign. What would you do first to solve this? Well, we'd probably move our number over by adding 7 each side. Over here, I'd have minus 3x. Negative 7, positive 7, go to 0. 12 plus 7 is 19. And now I'm fairly certain that this was first quoted by Shakespeare. To reverse or not to reverse? That is the question. Ha, ha, ha. All right, so do I need to reverse my inequality? Did I multiply or divide? No, I did not. I don't have to worry about it being a positive number because I'm adding. All right, so my inequality is going to stay where it is. Now, to get rid of the minus 3, I'm going to have to divide each side by minus 3. These cancel, leave me x. 19 over negative 3 is just negative 19 over 3. And now I ask the question, to reverse or not to reverse? Well, I divided, right, by negative 3. What does my rule say? I divided, it was negative, so I must reverse the inequality. So this is going to get reversed. X greater than or equal to negative 19 over 3. In interval notation, the smallest value that works is negative 19 over 3. The largest value would be infinity. Always use a round bracket with infinity. I see I have an equal sign here, so I'm going to put a square bracket on negative 19 over 3. Moving to our next example. Again, we want to get all our variables on one side, all our numbers on the other. I'm just going to add 2x, both sides. Here I have 4, 9x minus 5. To reverse or not to reverse? Well, I added a 2x, so my rule does not come into play. It only comes into play when we add and subtract. Scratch that, multiply and divide. All right, I'm going to add 5 each side. I get 9, 9x. We have added, so my rule does not come into play. And for my last step, I want to get rid of the 9. Divide by 9, divide by 9. Here we get x, here we get 1. Do we need to reverse? Well, we are dividing, so that part is a check. But is our number negative? No, it is positive, so we leave it alone. X greater than or equal to, or x is less than or equal to 1. So what's the largest value this can take on is 1. The smallest would be negative infinity. Round bracket, square bracket. One final example. All right. Just like with equations, if you get confused, say, what would I do if this was an equation? We would have to distribute our number through. Minus 3x plus 12. minus 6x minus 8. Now we did multiply by a negative number, but we didn't go on each side, okay? So we don't need to worry about reversing until we do something on each side, okay? All right, so now we want to get all our variables on one side, all our numbers on the other. I'll add 3x, 12 minus 3x minus 8. Do I need to reverse? No, I added 3x. My rule only comes into play when we multiply and divide. I'm going to add 8 each side. Does my rule come into play? No, I added 8. It only comes into play when we multiply and divide. For my last step, I'm going to divide by negative 3 each side. Here, this is just negative 20 over 3. These cancel out and leave me x. Do I need to reverse? Well, I divided by negative 3. So going back to my rule, I divided, check. It was a negative number, so I must reverse. So this is going to go this way. The smallest value that'll ever make this true is negative 20 over 3. The largest is infinity. No equal sign, so they're both getting rounded brackets. All right, I hope this helps. And again, remember, when we solve inequalities, just one new rule. If we multiply or divide by a negative number, we must reverse the inequality.